Started. So hello, everybody. Welcome to my talk, Git, the other database you need to know, here at SQL Start 2022. I'm very happy to be with you today. My name is Dwayne. I am a developer evangelist. I help people figure things out. I write blogs. I maintain a community here at Git Kraken. Talk more about Git Kraken here in a second. I live in Chicago, Illinois. It is 8:15 in the morning for me on a Friday, but I'm very, very thrilled to be here. Very excited to be presenting to this conference. So no matter where you are in the world, thank you for attending, and I'll start digging in. So as I mentioned, I work for Git Kraken. We are a company that makes Git tools. So if you are working with Git on the desktop, we make a Git GUI client, Git Kraken client. It makes it a little easier and safer to use Git and gets you to some of the power features a little faster because you can drag and drop things instead of just having to memorize commands. And also has things like an undo button to make it a little quicker and easier to use. If you're a VS Code user, Visual Studio Code, you're probably already using Git Lens. Millions and millions of people are. But Git Lens is an extension that unleashes the power of Git in the world's favorite code editor. It gives inline blame information and unlocks a lot of the power tools of Git within VS Code. And the last thing, we make Git integration for Jira. This is an awesome tool that does just what it says. It integrates Git into your Jira instances. So developers can more easily update Jira without breaking their workflow. They stay working in Git. Meanwhile, managers and key stakeholders get an updated Jira instance and everybody's happy. So that's what we make. You'll see me talk about Git Kraken client a little bit later when I'm talking about GUIs, but you might be asking, what is a talk about Git doing here at SQL, SQL Start 2022? Well, we all need to share files. We all need to share things, whether it's code, if you are on that end of it, or if you're working as a DBA and just administering the database, there's still things you need to share. Config, test, query libraries. In my research for putting this talk together, that was a use case I ran into time and time again of people needing to share query libraries. There's a lot of things you probably know much better than I do about the use cases for sharing documents, but file sharing is a very perilous thing. It's something that there's a lot of problems with, and the two major problems with it I'll talk about later when we talk about where Git came from. And Git provides a way to give you a way to review changes before those changes make their way into production. It's got this really cool superpower of branching, which we'll get into. And lastly, no matter where you're working around a database, no matter where you're positioned in relation to it, you're probably somewhere in a DevOps pipeline as well, a CI/CD pipeline. All modern DevOps is built on the back of Git. You don't necessarily 100% need Git to make a CI/CD pipeline, but that is how it's been built. That is, the vast majority of tools assume Git is there. So who is this talk really for? If you are more on the DBA side than the developer side, then I think you're going to get a lot out of this talk. That's really who I wrote this for, is folks that aren't developers. If you are a developer, you're probably going to get something out of this talk as well, because I'm going to be talking about some of the fundamental concepts of Git and explaining them in ways that maybe you haven't really thought about Git before. But at the end, I want to bridge us all together and have everyone, excuse the background noise if you can hear that, and have everyone on the same page about what Git is and how to use it. And what we're going to see the rest of this talk for the rest of the hour, I'm going to go over a high-level history of Git and conceptually how it works. I'll be actually talking about concepts throughout. And then we'll actually talk about how to get started. So if you're not using Git, if you don't even know if Git is installed on your machine, I'm going to invite you to play along at home. If you have a second monitor, start doing what you see on the screen, and we'll get you up and running before the end of this talk. Let's talk about checkout and branching and some strategies there. I'm actually going to address the CLI versus not CLI problem. Our decision, it's not a problem, it's a decision. And find surprise, I'll spoil it now. You don't really need to choose between, it's not an either or, it's a, what's the right tool for what I'm doing at the moment. And ultimately, Git is about sharing work. So we'll talk about how to share your code and repositories between machines. And then I'm going to end with a real world example with a repository you can actually get your hands on and play with yourself. So before I go any further, you're not going to walk out of here a Git expert unless you started this session as a Git expert. My goal is really to open up a lot of ideas and show you a lot of examples of how things work. But the only way to really learn is to do it. That's the point of this book, which is a really good book if you ever get a chance to read it. But it's about doing the thing is the only way to learn the thing. So that's what I would encourage you to do, is follow along with the examples, really practice this and make it your own. So why did I call this the other database you need to know? I have a particular worldview because I have a background in Drupal and WordPress and traditional web application architecture. From a certain worldview like mine, everything is just a modeled way to get at a database, to store things in a database and to retrieve things from a database. I can abstract the file system out to completely other services, and I don't need to worry about that. I can just call files from another service. I can take my app logic and put it into the browser or pull it all back out of the browser. These things are all changeable around. The one constant in a good web application is a database layer, whether it's a relational database or whether it's a NoSQL database. There's still a data layer there that's super important to make everything happen. It's the critical component. That's how I personally think about Git. Git is this critical central component to CI/CD, to all the DevOps work we do, but also in how we move code around and how we evolve code over time. It's that same worldview that no matter what you're actually doing with it, there's that central component that has to be there for us to do our work today. Same way that a database works in the stack. That's why I personally feel it's the other database you need to know about. There is internally language called the Git database, but we're not really going to get into that level of granularity with how Git works. Just wanted to clarify that in case you're wondering why I called Git a database. But what Git is a free and distributed, free open source distributed version control system. Version control is simply the idea that you're tracking versions. So you have a file, you make changes to it, and then you write down what you did to make those changes, and you explain yourself as the author of those changes. Then save those files, make changes again, save them again, and then again write down what you changed. Write down some kind of an explanation for yourself in the future or for other people that will see those changes. And we repeat the process. That's the basic idea of version control. There's a lot of ways to accomplish that. Git is one of the ways to accomplish that. It was created as a concept or as a command line tool and as a specific set of protocols and agreements by a guy you might have seen before, Linus Torvalds, a creator of the Linux project, or Linux project, depending on where you are in the world and how you pronounce it. But very quickly after he created it to solve his particular use case, Junio, or Gitster, took over the project just a few months later, and he's been maintaining it ever since. It's 24 or 22 years now, or I'm sorry, 17 years now of Git, and Junio being in charge. They were solving a very specific problem of a lot of developers around the world needing to collaborate and get to the correct version of something that they can then say this is the version we're putting in the kernel. The basic two problems that he was facing with a bunch of patches that people submitted to him, Linus that is, Linus was submitted patches for the Linux kernel, was which is the final version, which is the correct version that I should put in. Over here on the left, I think we've all been there. If you are naming a file locally, you've probably done this at some point in your life. Final version, final 2, final 6, final 8, and then just it gets longer and longer. Which is the actual correct last version? Git solves that, because the version you're looking at, if you're going to check out the production branch, that's the version we've said goes to production. If you're checking out the test branch, that's the version of things that, well, you're testing, so on and so forth. It's very easy to keep track of what's the final version. The other problem with file sharing that they were trying to solve is if you use a central server model for sharing any kind of document, you have these race conditions that if two people submit changes one right after another, here a minute apart, in this scenario, in most use cases, in most systems, traditionally, then the blue player would overwrite all the changes and their changes would go in and yellows would be lost. Those are the two fundamental problems that Git addresses. There's other things it does and there's other reasons it exists, but this is really boiled down why it's there. So how Git is different, how it works differently than other systems. Git is unique, and it was, at least at the time, it was unique, that it takes full snapshots of your file system. So when you are committing, that the individual unit of work in Git is called commit. Every commit, you take a snapshot of the entire file system, compress it down, and then take a checksum of that very, very, very compressed binary, and that's how we track things over time. We're not just storing diffs. We're not just storing the changes. We're taking full-on snapshots. The power of that is that we can always jump back in time and go back to those full snapshots and take a look at them and modify them and take code from them and do whatever we want. It's very efficient at what it does. Every snapshot then gets piled into a graph, and we can think of these things in graph terms. Over there on the right, that's the Git Kraken client, showing all of the commits as little notes on nodules in a graph view. But really, we're just stacking them up on top of each other. Git also has this really awesome superpower of letting us make parallel realities, that we're not limited to just one set of linear set of commits. We can have feature branches and test branches and QA branches and all sorts of other branches that we can merge and diverge from. Sometimes they don't come back together. It also lets us time travel, but we'll talk about that more a little bit later. And one of the real reasons Git became the de facto way that we share code is that it makes it so easy to share code. Git is extremely lightweight and extremely efficient because it compresses the file system down. Oops, excuse me there. Because it compresses the file system down the way it does, it's very lightweight to move things between computers. Entire services sprung up around this idea. GitHub was first, followed by GitLab, Bitbucket, Azure DevOps, current tools like Git all rely on Git to do what they do. All of these services, of course, build additional functionality on top of the back of Git. But the biggest takeaway here, if you're new to Git, is that early on, it's pretty easy to get confused with, hey, I need GitHub or a GitLab account to do my work. That might be true, but you don't, in the strictest sense of the term, need to use any of these services to use Git. Git is always local. So you can always use it. So even if you're using it just for your local project, for something you're doing just on your machine, you don't need any of these services to do that. Git doesn't rely on GitHub, but GitHub 100% relies on Git. Last two ideas, big ideas, before we'll move on to get more practical things. I'm seeing about on time for this. Git is a distributed version control system, meaning every single person who has a copy of the code base, a copy of the repository, has an official version of the repository and code base. To Git, there's no mechanism inside of Git that says this is the official version. We as human beings can declare this version sitting on this server is the official version. This is the canonical final version of Git that you should download. This is the version of the software that you want to get your hands on. But that's a human agreement. To Git the software, there's no central one true master or main. The other thing to keep in mind, and this is a really weird concept with Git, at least to me, it's always been weird, that everything to Git is always local to Git's point of view. The same way that your terminal, if you open a terminal tab or a terminal window, from that shell's perspective, that's what files it's seeing. That's what directory it's in. Git works kind of the same way because it's also working to track a file system. Everything's always local to Git's point of view. So if you are pushing, you're pushing away from whatever you're looking at with Git. If you're pulling into whatever Git is. I like this picture because this is in Oakland, California. There's a here and a there sign, and Git is kind of like that. So even if you are here in this picture, then you are here. But if you are here in this picture, even though you're there, you're still here to you. And you, where you're sitting right now watching this, you are here from your point of view. If you keep that in mind, a lot of things in Git become a little bit simpler because which direction things go, they always go in the direction relational to where here is from Git's point of view. I like talking about that, so I'll move on. But it's a fun thing to think about. So here we're going to actually get started. If you are playing along at home, we're going to talk about installing the program itself. I'm not going to get into the mechanics of how the C libraries work that make Git actually do what it does as a command line tool. All we're going to do is install it and talk about how it works, but we're not going to talk about the inner workings of Git today. That's another talk for another time. The next thing we're going to do after installing it is set some settings, configure some settings to let Git know who you are. It's very important. And then after that, we'll actually dig into using Git. There's a website, gitscm.com. This is the official website for the Git project. This is where you can download the official version of Git. If you are on Linux, you probably already have Git installed. If you are on Mac or Windows, depending on your development setup, you might already have Git there. If you open a terminal window and just type Git, it should bring up a help screen or Git -- version, and that would tell you what version of Git you're on. After it's installed, you just go through your package manager or installer. Pretty straightforward. But after it's installed, we need to tell Git who you are. If you're just working locally, this is actually an optional step. If you're never going to share your code, you don't really have to do this. It will just default to the local names. But if you're ever going to push that code anywhere, that's how you're communicating to the world who made that change. So you set it with your username and your email. Emails just default kind of become the unique identifier within the Git ecosystem, like you'd have a unique identifier in your database. This last one is optional, but very highly recommended. Previously with Git, the main branch that it would make would be called master. For a lot of reasons, we have decided that's not a great idea. So if you set this setting, it will make branch main. And that's a good thing. But what does that do? What do the commands do? Because I know I dropped this right into command lines. All those commands do is they write to a git config file. You could actually set this by hand if you wanted to. You could actually create a git config file and write this out. It would do the exact same thing. This is simply the file that Git looks in Every time it goes to do something, it says, all right, I know who my user is and I know who how to initialize things. You notice I've blocked out my signing key. I didn't really see a reason to share that with y'all, but you can have a lot of things you can configure. There's an awful lot of ways you can configure Git, but when you're getting started, these three are like the bare minimum I would recommend. Then you're ready to go. That is your initial setup. Now you have Git on your machine configured, ready to roll. So if you're starting a brand new project, you will initiate the project with git init. And git init builds you a Git. The Git folder looks like this. There's a lot in here. We're not going to dive through all of it. I am going to talk about a couple components in here, but this is how Git is actually how it interacts with the folder system. The big takeaway and why I'm showing this is to show the file sizes over here. These are very, very small files, like head, a very important pointer, a very important concept in Git, but it's 31 bytes big. The index is 8K. This is the biggest file in here because down version of your working directory. This is a copy of your file system that you're working in with the actual active files, and it's only 8K. And I'm working, in this case, this is it came out of working with a very large repository. So this is how lightweight Git is. I mentioned head there. Head, if we think back a few slides, is to think about everything is local. Everything is relational to where head is pointing. Head is simply a little tiny file that keeps track of what reference you're actually pointing at. What's the perspective of Git? So if you ever get into a detached head state, we'll talk about that a little bit later. Don't panic. It's just head is pointing at something that's not named main. Head is just pointing at a commit that's somewhere. That's what it means detached. It's not pointing at the tip of a branch. It's pointing just somewhere else out in space. Conceptually, this is what that looks like when you're in the state we're in right here, where we're at main. Head, the point of view of Git, that's an easier way to think about it, I think. It's just they called it head in all capital letters to make it easy to read. But the conceptual here, where we're pointing at with Git, in this case, we're pointing at main. Main itself is just a pointer, a human readable pointer that points to the last commit in this chain of commits. All of these commits, why they're numbers, let's talk about what's in a commit real quick. This is something I wish someone would explain to me early on when I was learning Git. I think they tried, I just didn't hear them. I mentioned Git takes an entire snapshot of the file system at a state in time. Every file in that file system that's been changed, been modified and saved, is then compressed down into this working tree. What we called indexed earlier, that's your working tree. It's keeping track of these compressed files. And every time you compress a file, we run a checksum using SHA, SHA, either 1 or 256. SHA-1 was the traditional way, but we still say a SHA, a checksum. That's the number that if we use it algorithmically, we can get back to this full blob. Blob stands for binary large object. So we take the whole large object, press it down, take a list of all of those objects that we're tracking, and then we make a commit. We write down a message and an author of who actually made all of these changes that go to all of these individual files with all of their changes. That's what all of these represent, is this view that we've compressed this tree, this list of files that have been changed. Git is extremely lightweight, like I mentioned. Made a new commit, but the file has not changed. So these are the same file changed. Now we have version 2 of this one. In these cases, we're not making new snapshots of these files. what we do is simply point back in time. Yeah, we point back in time to the commit before it. That's how we end up with these chains. That's what we mean by chain of commits, is that inside of each commit, there is a reference to the previous commit, and if we're looking at that version of a file. Again, we're talking about bytes, individual bytes of code that let us do it this way. So I know that's a lot to think about, but that's how Git works internally. Getting back on track with using Git, I always think it's important to understand a little bit of why and how when we're talking about any of these concepts. Don't worry, we won't get into that level of detail much beyond this. Most of the time, you're not going to run a Git init. The Git folder is already going to be there because most of the time you're going to be working with code. At least in my experience, you were starting from someone else's work. And that's what clone is all about. If you ever heard someone say, clone down my repo, what they're saying is make a copy of this repository that's on a server somewhere, copy it down to my local machine, but also keep track of what's going on with that remote server. There's this concept in Git of upstream and downstream. Upstream, you can make changes that then you can pull down to your local machine or then push them up to that server. That's the up and down of up and downstream. Clone just gets us the code and sets up that remote situation all at the same time. Most of the time when you're using Git, I would say 85 to 90% of the use case of Git is these two commands. After your setup, that is. You're working in something called a working directory. This is simply your file system. If you have VS Code or an IDE or any tool open that you're manipulating files with, that's what you're actually looking at. You're working at, from Git's perspective, Git's local perspective, a working directory. You're doing your work, you're making your changes, you're making your edits, you're saving. At some point, you're saying, okay, I would like to save this version of my work. That's what git add is. You can simply then git add those tricks to add everything, or git add period to add the entire folder you're in and all recursive folders down. Git add into the staging area. That's that index file I mentioned earlier. That's where it actually gets. And then when we're actually ready to commit and we've added all the files we need to add, then we do our git commit, write our message as an author to say, this is what I changed. This is why I changed it. You can reference issue queue numbers. You can put organizational specific information in there, whatever you need to do to make that message. So long-term in the repository, you can look back in time and see what you did. Now, what this actually looks like is closer to this. What you'll find in Git is that sometimes it's easier to explain a concept one way, but in all reality, it works slightly differently. And that's okay. But this is part of why people get confused with Git. From Git's point of view, you have things that it's not keeping track of, things that you've never told it to keep track of, you've never added, things that are that have been added that Git knows to track that haven't been modified, things that Git knows to track that it knows have been modified, and then there's the index where you've pushed things to be staged. Once you made a commit, then those things go back to being unmodified, and you start the cycle over, unmodified, modified, staged. Make a new file, it's not being tracked yet. You then add it, and it becomes modified and staged. Commit it, it comes back to unmodified. Don't worry if that's confusing. This comes directly out of the Pro Git book. I'll mention it at the end. Highly recommend reading it. It's really, really good book. There we go. Moving on to the next slide. At any point in time, you can look back at your history. You can look at your Git log. And that's what the command is, Git log. This is a very safe command. You should feel free to run this as often as you feel like. There's a lot of variations on how to run it. You can do it as one line. So every commit is simply one line. So you get a very condensed view of things. You can do it very verbose and see much more information. You can do it in graph form. There's a lot of ways to look at this, but you can always look back at your history and see the commit SHA, the checksum of that particular commit that we can always get back to and get back to that state and see the author, the date, and what they've done. Git status is another really awesome command that you can run as often as you want. It's something you should run often. It tells you the state of Git. So it tells you what files it can see. It can see, in this case, these 3 have been committed yet. And it even tells me the change is not staged for commit. Oh, these actually haven't been added. So to add these, it even tells me exactly. Very well done as far as in a lot of cases. Not every case, you'll find some error messages and some situations where it's not super clear, but in case, most of the time they're working on it to make it this clear. If you do check out a branch, if we say we wanted to go back in time to this commit, we would do something called git checkout. Git checkout moves the point of reference, our head, that pointer, simply back to that other commit. In this case, this would actually be called a detached head state, since it's not, head is not attached to the tip of the branch anymore. It's no longer pointing at the pointer main, which is simply a branch name. It's pointing at this particular commit, in this case, this commit. But I can check out any commit along that graph at any time, and then I have full access to all. I keep saying that main is a branch. Branches are simply human readable names that point to specific commits in a chain. Normally the last commit in a very specific chain. This is one of the concepts that's, when we first start thinking of it conceptually, it looks a little like this, that we have diverged off, and now we can still keep making commits up here, in this case, the master branch. We can still keep making commits here in the development branch, and we can still make changes out here in the topic branch. The reason this is powerful is that we can then merge these things back in. I'll talk about that here in a second. But as I mentioned, main is just the name of a branch. It just, by the way we set our config, the default first one that we set up. If we make another commit and we're still working from Git's point of view in main, then this commit would actually be in the main branch. What's happened here is while we're working here, we said Git branch, and then we named testing, and then it made a testing branch. Then we checked out the testing branch, Git checkout testing, and now we made a commit on the testing branch. In this particular instance, then we rechecked out main. So now testing is a branch that sits here, but from Git's point of view, we checked out main, which is still pointing at this one. So it's not really a diverged set of trees that looks like this. From Git's point of view, it's just a bunch of commits that are pointing at each other with references. Maybe that was more confusing than it needed to be, sorry. Git merge then will get us to make those commits come back together and then make a new commit. So we were on the main branch here. Back here, we made a new issue, branched off to issue 53, made 2 commits over here. Meanwhile, we made a commit on the main branch. And then C6 happened because we did a git merge. Now, if we're doing this from main's perspective, we say git merge issue 53 because we've checked out main, if head's pointing here. And now we've made a brand new commit, and that new commit is C6. Our branch still persists. We told main, or we told Git to make this part of main's branch, but meanwhile, this branch still persists. That's how merging works. You will inevitably run into merge conflicts. Do not feel bad. You should not feel bad about this. Git is literally the stupid content tracker. If you type man git, look at the Git manual. This is 100% true. It's the stupid content tracker. As soon as it gets confused, it simply gives up. But it doesn't just give up. It doesn't just fail, and it doesn't silently fail. It very loudly tells you, hey, I've hit a conflict. What it also does is inside the file where it's hit that conflict, it writes down a message and says, hey, from my point of view, where you were trying to merge from, head said this is the true version. But this other version that you're trying to merge in from Mundo, in this case, says this version's true. I don't know what to do, so I give up. When you run into merge conflicts, all you have to do is run a git status that will show you what didn't get merged, and it will show you, hey, these files have not been staged. I didn't know what to do with them. Go look in those files. The easiest thing to do is just look for head, do a control F or search for the word head, find where something looks like this, modify it so it looks correct. In this case, let's choose hello Mundo. So I'd erase Mundo, I'd erase this line, and this line, and then we say def hello puts hello Mundo end. That will look good to me. I would simply save that, git add, git commit, and I'm right back to good. Merge conflicts don't need to be scary. If we know how to approach them, they're annoying. Don't get me wrong, no one wants a merge conflict, but they shouldn't terrify you and should never feel bad about them. There are a ton of tools to also help with this, where you can apply certain strategies to say, always take the thing that's coming in, take theirs, or always take mine, X ours or X theirs. The last major thing to talk about is, now that we've made our changes locally, now that we've made our merges and done what we've done, now let's talk about sharing those repositories and sharing those out with services. The three commands you'll run into by far the most when working with remote servers are these three. Git fetch, which will go grab all of the changes that exist on that remote server but don't exist locally, and simply pull them down. It don't do anything else with them, but now they're in your working directory, and you can see what are the changes that have been made on the server. You can fully review them. If you want to, then merge them in. Do a git merge after that. Git pull assumes that you want to go ahead and do that merge. You'll probably end up using git pull more than you'll use git fetch, and it will simply fetch and merge those changes in your local. Git push is when you've made those changes and you want them to go to Git. There's a little more to it. You'll explain what origin you're actually pushing to in most cases, like origin or whatever you called your remote. And then in most cases, git push origin main is the most common thing you'll probably see. I actually have that aliased on my machine as GPOM. So I say GPOM, my computer just does a git push origin main. And for most cases, that's what I wanted to do. I mentioned earlier that these services provide other functions. The biggest thing that they provide, and why GitHub got so popular, I believe, is that it provided this thing called a pull request, which is just a way to have a conversation with the owner. Hey, person who's in charge of this repository, pull in my changes. I'd like to improve this repo, and here's the way I'd like to improve it. GitHub's issue queue system is legendarily cool. Tools, much more recently, they've added project management tools, and every service is a little different. GitLab was CD tools, and now everybody does. And they keep doing more and more things. So find the one that's right for you if you're building this from scratch. Otherwise, I'd recommend starting with GitHub or GitLab. Maybe Bitbucket, depending on if you like Atlassian. So conceptually, what should we store in Git? Anything that you can write down in a text file is a great idea to store in Git. Anything that needs to be versioned over time, literally anything. Configuration settings, documentation. Documentation is actually an amazing use case for Git, because then we can always go back and see what previous versions of our documentation. And with these help of these services, we can open up our documentation and let the community help us write the documentation in a very straightforward way that makes a lot of sense to everyone involved. Very related to that idea is learning Markdown, which is a way to add styling consistently across text files. It's just a standard way to mark down files. Not everything should be stored in Git, though. Never put secrets in Git. If it's a password, if it's an API key, if it's something that would cause damage to your organization, do not put it in your code, ever. There are other services for that, key vaults, AWS Secrets. There are a lot of services that are good at this. Do not, any customer personal identifying information. At some point, your code will be seen by someone who you don't want to have this information. It's cool if you see my JavaScript functions. It's not cool if you see my customer data. Always keep that in mind and don't hard code customer things. Any other sensitive data, internal memos, internal. If it's an external roadmap that you're sharing on a website, sure, put it in your code. If you could share it on your pretty good rule of thumb. These last two are a little more nuanced. You can put anything in Git. Anything. But it's good to keep a couple things in mind. One, Git really isn't a backup system. It can be part of a backup system, but when you're thinking about backups, and probably I'm preaching to a choir here, everybody probably already knows this, you should use a 3-2-1 strategy with backups. You should have 3 versions of your mission critical data in 2 completely different formats, and at least one of them needs to be located off-site. Git can be part of that. Git can be one of your backup strategy, part of that 3 strategy. And the other piece is large media files. Think about movie files and images and any large binaries. Git can, of course, track these things, and it's just taking a snapshot of the repository of the folder system. But over time, the large media files, if you keep adding them and you modify, say you have a gigabyte size movie that's part of, you replace that every couple of days. Like, all right, we made a new version of the movie. Because it's so big, even though it's compressed, that starts adding up very, very quickly. A compressed down gig is still pretty big in relation to like a text file. There is a service called Git LFS. It's built into all of the providers. It's a tool that moves the actual files off to a different service or a different server, and then replaces those in your repository with a 3-line pointer file, which is like 4 or 5. About 30 to 40 bytes. So very, very, very small. Probably want to just think through, do I, sorry about that. Large files, do I really want to? The answer is probably no. Everything I've talked about up till now, I have assumed we're using the CLI. Not everybody's a fan of the CLI, though. Not everybody's a fan of getting on the command line. I totally get that. Here's the thing, though. Git, at the same time, is a command line tool built by Linus and Gitster for people using Linux and building the Linux kernel. It's also a set of protocols and agreements and concepts to allow distributed version control to happen. See there. Sorry, I have a little bit of problem. It's a lag. Since Git is just a set of protocols from a certain point of view, we can abstract and use that in various ways. The biggest project that has abstracted out Git into portable C libraries is called libgit2. It's what GitHub and GitLab and all of those services are using. They're not running command line Git to accomplish Git on their servers. They're using a library that runs much more efficiently. And then someone took libgit2 and abstracted it out to Node, and then we have NodeGit. And there's a bunch of other versions that I haven't talked about. NodeGit is actually what runs underneath Git Kraken, my personal favorite GUI. But I'm not here to sell you Git Kraken. I'm here to bring it up, of course, and that's who sponsors me as a person to be here. But there are a lot of GUI clients, is my point. There's a lot of different options out there, depending on what operating system you're on, depending on how you want iOS. There's options there. The best canonical list of not approved, but vetted someone on the Git project. Go to gitscm.com/download/GUIs, and there's a bunch of options you can walk through there. I have a personal favorite, but find the one that's right. Up here in the next 5 minutes, but I want to talk about a practical example that you can play along with at home. So if you've never used Git, I invite you to install Git and then actually follow along with this practical example. I'll share my slides after this, and we will be able to. Let's say we have a scenario that we're creating something that's not even part of the thing that scares a lot of people when they first start with Git is, oh, it has to be a code project, and I don't really know code. So now create code and learn a new concept called Git. The good news is you don't. Git will work with any kind of files. So we can make something as simple as this, creating an onboard guide. I created a outline for an onboarding guide, and you can get it right now. If you go to github.com/example onboarding guide, we'll share this link out as well, and you can, as well as sharing these slides. But you could go and download that or clone it, forking it. Forking is a term that we use in these services. It's over here. If you are looking at the repo, fork simply says make a copy of this repo over on my account on this service. So in GitHub, for instance, you would have your username, and then it would be the same name for the repo, but that's what your URL would be. Just replace my name with your name after you forked this repo. The advantage of doing that is then you completely control that repo. You can push to it. You can modify as you see fit, and it won't affect my version. If you wanted me to make a change to my version based on the changes you made to your version, that's what a pull request is. First step toward making a pull request, but not 100% necessary. You can just clone it and just get the code down. You won't be able to push your changes back up to me, but if you're just using it locally or going to push it somewhere else, that's fine too. Git clone, we already talked about that. We'll go to the clone code section in GitHub, open it up, Git. Could use the HTTPS or the SSH, doesn't matter, and then clone it down to our local machines. Once we have it locally, we could go ahead and just start editing. Totally up to you. However, I like the workflow where I always work in a feature branch. A little bit more safety. In this case, I made a new branch called Daily Queries. And if I don't like what I'm doing here. I don't like the way this looks. I want to start over. All I have to do is check out main, and I'm right back to where I left off. I can delete that branch and start all over again. Gives me a lot of safety. And I can keep it change somewhere else out my main branch. It won't affect my daily query branch until I want to merge, and vice versa. So it gives me a lot of safety to work that way. So after I make my changes, added the files that I wanted to in my member repo, I'm happy with that. I will git add, git commit, and then I'll go ahead and merge those changes into my repo. Is this? Oh, okay. All right. Now I could use a GUI for this, as well as the command line. In fact, that's one of the reasons I like Git Kraken is that we have a terminal panel built into our GUI. So I can jump back and forth depending on how I prefer to work at that particular moment. But I could, stage my files, write my commit messages this way as well. Like I say, when I'm done with my work, I added my committed. I will then go ahead and merge it. I can merge it again through the command line, through a GUI. So I merge those changes back into my main branch, and then I push those changes back to my fork. In this case, since I'm not working with a fork, I'm working way up. And that's what I said earlier, git push origin main. And it pushed that branch, the main branch, back up to that fork. So I know I went really quick there. And again, I don't expect anyone to walk out of here fully a Git expert based on just watching this talk if you haven't used Git before. But if you came in as a Git expert, hopefully you found something amusing here and maybe learned something. But what we did is you're using an open source project, cloned it locally, made a branch to work in, did your work, added, committed, and merged those changes, and you push those changes back to a repo for distribution for other people to find. There's a lot of resources for Git. If nothing else, Git is the best documented tool maybe in the history of the world. It really is. There are hundreds and hundreds of guides people have written, dozens of books I can name. The best book I can possibly tell you to read, though, is this one, the Pro Git book. It's very complex in the middle, but it is the definitive source of how Git works. Actual documentation. There's also all sorts of visual guides and cheat sheets, and we break things down very simply in our Learn Git pages on the Git Kraken website. Like I mentioned, there's GUIs you can use. If you want to use the Git Kraken client, I'd highly recommend it. It's free to download and free to use for open source projects. And there's tons of online sources. Codecademy is actually one of the ones that I went through when I was first learning Git back in early part of 2010s. And it's gotten a lot when I first took it. And here's a website that you should bookmark if you're using Git. Dang it, Git. It's a website that provides a lot of very short snippets of help to get you out of very common situations that people run into when they're working with Git. And that's it. I know I covered an awful lot, and I kind of went, and I apologize if I went too fast in certain parts, but I'm completely happy to answer any questions you have now. And if you can't ask a question over Teams, over this particular conference technology, feel free to reach out to me at my email or hit me up on Twitter. I'm always available on Twitter, and I'm always other things I'm interested in, like rock and roll or karaoke or knitting and crochet or improv, but pretty much anything. But if you have any questions at all, feel free to ask here or there over on Twitter. And Sergio, are you still there?
Yeah, I'm here. No question for the moment in the Q&A queue. Okay, there is a question. Can you see it or?
I cannot see. No, from the way I'm sharing my screen, I can actually see the menu.
Okay, the question is, what about tracking package? Is it possible?
The short answer is yes. Any file can be tracked. As I mentioned, go back here. Anything can be tracked. Git is just taking a snapshot of your file system. No matter even if it's a giant movie file, it will still take that snapshot. You can store anything in there. it's not a great idea to store very large things, simply because of, but over time, it will start slowing down your use of Git. Like Git itself will start slowing down how fast it will do things like checkouts or pushes, but it's still possible to do it that way. But also keep in mind that it's not truly a backup. So if you're thinking about, can I back up my SSIS files? It's part of the strategy, but not the full strategy. And hopefully that answers the question.
Okay. In addition, SSIS package, it could be basically on XML language. So XML is a text. So yep. If this is the case, Git repositories, yep. It could be good because when you have text, it's okay. This is my opinion.
Yes, no, your opinion is very correct. I didn't really hear what you the type of file you said, but if it's XML, absolutely. XML files are very good to store. Doesn't matter how big that XML file is, it's just a text file. That's a very good thing to store. I got it at the bottom. Oh, I guess earlier, because of the way it was lagging, I skipped this slide here just to show it. What I have found in my work is that 95% of all of the use cases I've ever run into with Git are covered by these 16 commands. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 commands. At one time I had 18 commands on here, but these 15 commands cover 95% of the use case of Git. In fact, most of the time you never run an init. Revert is a very special use case. Remotes read-only. Oh, it can be read-only. You can make new remotes with it, but something you don't use all that super often. Occasionally. But if you're a command line person, this is basically it. If you memorize what all of these 15 do, then you are pretty good to go, again, 95% of the time. Transition to talk about GUIs. So GUIs are great. I personally like using graphical user interfaces just to keep track of where I am with branching and merging. And it's just easier to see things like that visually, because conceptually they work visually like that. So easier for me, but there's no right or wrong to it. At the end of the day, they both accomplish the same thing. They both accomplish Git.
Okay, no more question. No, so one more question. Okay, thank you. I knew it's not possible in general.
Yep. Well, I'm sorry, what was the question there?
Okay. So it was the answer. SSIS package.
Oh, I see. It's good, very good. Perfecto, as they say. Excuse. I'm American, live in Chicago, so I don't speak anything but English.
Don't worry.
I very much appreciate the patience and understanding.
No, don't worry.
All right. Well, I think we're out of time then. Thank you very much, everyone. It's been a very good pleasure to be here. I've very much enjoyed giving this presentation. Hopefully, everyone out there was able to learn something, and I believe this will be made available later, correct?
Yeah.
Very good.
Thank you very much. Thank you very much, Darian. Thank you very much. It was a pleasure to have you in this conference, and Have a nice day for the rest of in your time zone.
Very good. All right. Thank you so much. Have a good day. Bye-bye.
Thank you very much. Bye-bye. Bye-bye.